Sounds pretty simple, right? Well, the more questions I asked, and the deeper I delved into it, the more I realized that I didn't understand what was going on. Let's break it down into smaller questions which should be easier to answer. So what does it mean for something to burn? Well, burning by definition is when something reacts with oxygen in order to produce flames. And this is also known as combustion. But what do we need for something to burn? First of all, we need a fuel and we need oxygen. So a fuel is something which just reacts with oxygen. Second of all, we need a source of ignition. And this is just something which provides energy to get the reaction started. And third of all, we need a chemical chain reaction. This just means that there needs to be enough fuel and oxygen and in the correct conditions for the reaction to keep going. Okay, that's all well and good, but what does it mean for something to burn? What does it actually mean? Okay, let's start off with a source of ignition. It could be a flame, it could be a spark, it could be something hot. Now what this does is it gives an oxygen molecule a kick, making it move faster. Oxygen molecule meaning two oxygen atoms joined together. Okay, this oxygen molecule now shoots into a carbon atom. Yeah? This carbon atom could be anywhere. It could be in a piece of wood. It could be something else as well. It doesn't have to be carbon. But all that matters is that it's a fuel particle. So, taking this example, this oxygen molecule shoots into this piece of wood and you've got a carbon atom there. Well, under normal circumstances, the oxygen molecule and the carbon atom wouldn't get anywhere near each other because they'd repel each other. But because the oxygen molecule is supersonic, it's going so quickly, it overcomes the repulsion. Now, when they get close enough, they just snap together and release so much energy in the process. And then all the nearby oxygen molecules and carbon atoms, they start combining together too, and then it becomes a massive catastrophe. All of them start mixing together, and then you get really, really quick carbon dioxide molecules, carbon monoxide molecules, basically just molecules of the gas that makes up the flame, moving about really quickly. And that means that we've got a hot gas. So this is why fires are hot. But what are the flames? Okay, because these atoms are moving about really quickly and they're just hitting each other, constantly jiggling about, they've got a lot of energy. And what this energy does, it makes the electrons in the atoms get excited. What I mean is that they get more energy. And what this energy does is it causes it to move up to a higher energy level, just like leveling up in a video game. But unlike that, you can level down too. So the electrons then move down to their original energy state, their ground state. And when they do that, they emit light. And in different substances, the electrons gain different amounts of energy. And then when they drop back down, they emit different types of light, different colors of light. That's why different substances burn with different flames. So that explains why we see flames and why fires are hot. What's a magnifying glass? Well, the glass part of a magnifying glass is what's known as a convex lens. What does that mean? That just means that the glass bulges outwards from the center line. A lens is just something which changes the direction of light, and a convex lens changes the direction of light so that it points towards an imaginary line running through the center point of the lens. How does it magnify stuff there? When you move that convex lens close to an object so that it's closer than a distance called the focal distance, then what happens is that the convex lens changes the direction of light coming from that object so that it appears to have come from a bigger object. It just changes the direction of light so that it traces back to a bigger object, and our brain gets fooled by it. Okay, but what does this have to do with it focusing the rays of sunlight at a single point? Well, not much really. The sun's really far away, so by the time the light from it reaches us, it will be mostly parallel, because the rays of light which aren't parallel would have gone elsewhere. And what's special about a convex lens is that it focuses parallel rays of light at a single point. Well, now we have the tools to answer our initial question. Why does paper burn under a magnifying glass in sunlight? So our magnifying glass concentrates the rays of sunlight at a single point, and light is a form of energy, and the sun emits very high energy light compared to your common light bulb. What the magnifying glass does is concentrate the rays at this point. All this energy gets concentrated at this point and dumped into the paper. The paper absorbs it, and cellulose molecules in the paper start jiggling about. Cellulose is a molecule which makes up plants, and paper is made out of trees, therefore your paper also contains cellulose molecules. Now, these cellulose molecules start jiggling about really fast, and what happens is that they can't withstand it, so they start breaking down. They break down into a mixture of gases commonly known as wood gas. So the molecules from the breaking down of cellulose make up this wood gas. Now, this wood gas is quite hot, and the molecules in it are moving about really quickly. What happens when one of the molecules in the wood gas gets close to oxygen? It snaps together, and a bunch of others do so as well, and you get a terrible commotion known as a fire. That explains the question. But usually when you do it, you don't really see any flame if you're just burning paper. That's probably because you don't have enough fuel for a chemical chain reaction. You see, paper's quite thin, and therefore when you burn it, there's not gonna be enough fuel there for the chemical chain reaction. So if you try putting some hay on top or some shredded paper on top, you might be able to get there to be a nice looking flame, but otherwise the flame is quite small and doesn't last very long, so it's not really noticeable.